So let's get started with feature engineering. Feature engineering or just getting the most out of the data from predictive models. ठीक है, चलो. Let's get started, guys. So feature engineering, basically the first thing that comes to my mind while I read feature engineering is कि अपन from a data set we'll be selecting certain features that help in improvising our predictive models, predictive machine learning models. That is what comes to my mind when I listen to the term feature engineering. लिखते आगे क्या है. So here we have data, obviously we have features and we have the model. So data has features which helps us to build the model. Useful attributes for modeling task. Useful attributes for your modeling task. Feature engineering is the process of transforming raw data into features that better represent an underlying problem. Feature engineering is the process of transforming raw data into features. Feature engineering is the processing of transforming raw data into features that better represent an underlying problem to the predictive model, resulting in improved model accuracy of unseen data. क्या बोल रहा है यहाँ पे? फीचर इंजीनियरिंग एक प्रोसेस है जो रॉ डेटा को ट्रांसफॉर्म करता है इनटू बेटर फीचर दैट कैन रिप्रेजेंट द डेटा बेटरली. अरे दैट हैज़ अ बेटरली इज नॉट अ वर्ड, आई गेस. दैट हैज़ अ बेटर रिप्रेजेंटेशन ऑफ द डेटा, the underlying problem to the predictive model. So the better representation of the data is what will help us build a better predictive model. So, and a better predictive model will result in model accuracy on unseen data, more accuracy on the unseen data. So to frame it properly, feature engineering is the process of transforming raw data into features that better represent the underlying problem of the to the predictive model, resulting in improvised model accuracy on unseen data. Coming up with features is difficult. First, time consuming. Secondly, requires expert knowledge. Applied machine learning is basically feature engineering. So what does it say? Coming up with features is difficult. ठीक है. It is also time consuming. It requires expert knowledge. तीन चीज़ें. Difficult, time consuming, requires expert knowledge. Applied machine learning is basically feature engineering. ठीक है. Applied machine learning is basically feature engineering. The dream: raw data, data set, model, task. This is the dream. कि raw data डाला, data set बन गया, model, and the task is done. But this is not possible. You can't just provide raw data. You have to provide features. The reality: logs, text में से features extract करो, ML ready data set. You have to select a model, train it, and the task is done. Raw data also includes audio, video, pictures, everything. उनमें से फीचर एक्सट्रैक्शन करके तुम्हारा ML का डेटा सेट रेडी होगा. अनलाइक रॉ डेटा दिया और मशीन को सब खुद समझ में आ गया. Oracle, MySQL, Hadoop है, okay. MySQL, MSQL. Here are some feature engineering techniques for your data science toolbox. Wow. Case study. Outbrain click prediction. Kaggle competition. Can you predict which recommended content each user will click? Sample of users page views and clicking during 14 days of June 2016. 2 billion page views, 17 million clicks recorded, 700 million unique users, 560 sites. So here we have a website and we, by the help of the users that have visited this page in the span of 14 days, 2 billion page views, 17 million clicks recorded, 700 million unique users, उसमें से we have to use that data to find ki what is uh, gonna be the page ka part that is gonna be the most clicked. ठीक है. I got 19th position from about 100,000 अरे 1000 competitors. क्या पढ़ रहा हूँ मैं. I got 19th position from 1000 competitors. Top 2%, mostly due to feature engineering techniques. Who was this I? Wow, sir. Insane. Outwin click prediction. ठीक है. Data mugging. 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 Munching. Munging. What? Data what? How do you?
Mugging.
Mugging. Data mugging. First of all, a closer look at your data. What does data model look like? What is the feature distribution? What are the features with missing or inconsistent value? What are the most predictive features? Conduct an exploratory data analysis (EDA). First of all, a closer look at your data. Have a closer look at your data. What does the data model look like? ठीक है, पहले तो सोचो कि data model recognize क्या करने वाला है. What is the features that you're gonna need? What is the feature distribution that it is gonna need? What are the features with missing or inconsistent values? If that feature set is required, personal missing या inconsistent values है तो उसको fix करो. What are the most predictive features? If what was the predictive features as in which features which from the data set which features are gonna help you to develop better accuracy for your model. आउटब्रेन का क्लिक प्रिडिक्शन मॉडल है ये. न्यूमेरिकल टेम्पोरल स्पेशियल कैटेगोरिकल टारगेट. Believing that the model would start from okay तो events है इधर. This is click train, this is click test. ट्रेन करते वक्त promoted content, ad id, document id, campaign id, advertiser id, documents का मेटा डेटा, page view, document categories, document topics, document entities. Document entities, topics, categories, views combine to form document का metadata, which is a part of promoted content, click train and events. तो clicks train और clicks test is two things जहाँ पे we are using. clicks train में अपन ये सब यूटिलाइज कर रहे हैं क्लिक का वैल्यू के साथ, और क्लिक टेस्ट में वी आर एबल टू प्रिडिक्ट इट विदाउट क्लिक्स का वैल्यू के साथ. Tabular data, rows and columns, usually denormalized in a single file dataset. Each row contains information about one instance. Each column is a feature that describes a property of the instance. Each row contains information about one instance. तो अगर let's say eyes, nose, hair, सारे features है human face के, each row would describe one human face, and each column is a feature that describes property of one singular property of the instance. इतना तो easy था समझना. Usually denormalized in a single file dataset. Usually it is in a single file, CSV, JSON, जो भी है. Data cleansing, homogenize missing values and different types of homogenize missing values and different types of in the same feature. भाई ये लोग अजीब सा क्यों लिखते हैं. homogenize missing values and different types of data in the same feature, fix input errors, types, etc. Now, name है, और this is the original data, okay? Name है, date है, duration है, genre है और place है. Now names में all you can do is capitalization and shit if that is important. डेट के अंदर यू एक्चुअली हैव टू दैट द फॉर्मेटिंग, ये अलग अलग फॉर्मेटिंग नहीं चलेगा, सो यू मैच द सिंगुलर फॉर्मेटिंग जो ब्लैक में है. ड्यूरेशन सबका अलग है, दिस इज इन सेकेंड्स, दिस इज 5 minutes 32 seconds, दिस इज 4 minutes. सो यू नीड टू मेक हर एक का ड्यूरेशन सिमिलर, लाइक सिमिलर क्या, सेम डेटा टाइप होना चाहिए. जॉनर देख, अभी दो ब्लूज टू इन ह्यूमन एज राइट, बट डबल एस इज जस्ट समवन मस्ती, यू हैव टू करेक्ट दैट. प्लेस एन ए है तो एन ए तो चलेगा नहीं ट्रेन करते वक्त, इधर यू हैव टू पुट इट 0, तो वो कर लो. So that you can see all the values have been changed. They left it blank null, so they must have coded for that ki if there are null values, so how do you account for null values or blank values. Aggregating necessary when the entity to model is an aggregation. Why can't I read today? Fuck. Aggregating necessary when the entity to model is an aggregation from provided data. Necessary when the entity to the model is an aggregation from provided data. Let's see, I can't understand what this line is trying to say. Original data दिया, list of playbacks, content, genre, duration, playtime, user, device. ठीक है. Aggregate data, list of users. User है, number of playbacks, total time और preferred device. ठीक है. कंटेंट का तो फ़र्क ही नहीं पड़ रहा, वन सिंगुलर कंटेंट एल्बम इज नॉट गोना हेल्प. जॉनर could have been important if they were trying to train a model to suggest genres, but इधर the model is that कौन सा यूज़र कितना टाइम किधर स्पेंड कर रहा है और कितना प्लेबैक और कितना कौन से डिवाइस पे. ठीक है. विद दैट इन प्लेस we will move on to pivoting. Necessary when the entity to model is an aggregation from provided data. तो ये क्या था, entity to the model is an aggregation from the provided data, aggregating, pivoting. अच्छा, ओ preferred device, playback devices. Okay, so you're like detailing it down more. अगर preferred device is tablet, but obviously पूरा टाइम टैबलेट पे थोड़ी सुना रहेगा बंदा. नंबर ऑफ प्लेबैक्स 3 है, तो दो बार टैबलेट पे सुना, एक बार टीवी पे सुना, हैंस प्रेफर्ड इज टैबलेट. इसका 3 बार, 2 बार टीवी पे सुना, एक बार फ़ोन पे सुना, इसीलिए फेवरेट टीवी, क्योंकि 2 बार वो बंदा फ़ोन पे सुना. आई एम रियली इंटरेस्टेड, अगर इसका 3 होता है और ये सब 1 1 1 होता तो क्या आता, नल आता तो. बट play duration by, oh, then you have another quantity no to help you out. Play duration by device, इधर इसका टीवी का 1 है और 190 है, तब तो अपने को पता है टैबलेट है. इधर स्मार्टफोन टीवी 2:1 है, 750 296 521. And another thing, if this would have had more playback than the TV, तो भी मेरे को देखने क्या होता. wow, that's interesting though, that you can develop a preferred devices का database by like you can get the preferred device by splitting this data and finding कि ये सब कौन से instances में किधर हुआ था. तो ये यूज़र है, यूज़र 1 1 1, उसका ड्यूरेशन है, वह टीवी है. you are using this data to aggregate it down. wow, that is insane. like this is data aggregation only. समझा नहीं समझा, ये सारे यूज़र्स हैं, ये यूज़र का, हर यूज़र का वो है डेटा है, वो लॉग एक्चुअली. अदर टीवी है, मतलब यूज़र 1 टीवी टैबलेट, तो वी कैन से दैट प्रेफर्ड डिवाइस इज टैबलेट बिकॉज 2 बार प्ले हुआ है. टोटल टाइम तो वी कैन कैलकुलेट बाय ड्यूरेशन, बट देन वी कैन इवन स्प्लिट. ये टीवी पे 190 था, इस पर 640 था, Therefore, tablet is more favorite because ज़्यादा minutes are counted on tablet. Number of playbacks, so we can just count कितने बार the instances are occurring. That is for user one. Wow, that is insane. Numerical features. We get the numerical features. How? Usually easy to ingest by mathematical models. Usually easy to ingest by mathematical models. But feature engineering is indeed necessary. Can be floats, counts, etc. Easier to impute missing data. Averaging वो सब अपन ने पढ़ा था पहले. Distribution and scale matters to some models. Imputation for missing values. Data set contain missing values. Data sets contain missing values, often encoded as blanks, nans, or other placeholders. Ignoring row sorry. Uh, ignoring rows and columns with missing values is possible, but at the price of losing data which might be valuable. Ignoring rows and or columns with missing values is possible, but the price of losing data which might be valuable. Better strategies to infer them from known part of the data. Strategies mean, median, mode, using a model that can expose arithmetic bias. ये अपन ने पढ़ा है पहले. Binarization. Okay, so that would basically mean converting something to binary again. Transform discrete to or continuous numeric features in binary features. Example, number of user views of the same document. From SK learn import pre-processing. X equals to 1 minus 1 2 2 0 0 0 1 minus 1. ठीक है. List है ये 2D. Binarizer equals to pre-processing dot binarizer threshold is 1. Okay, threshold set किया ना, तो anything above 1 becomes this, anything below 1. Oh, that is such a fast way to do that. Binarizer pre-processing, binarizer threshold 1.0, binarizer transform x. अरे आ गया. इधर इधर threshold क्या दिया है? Threshold would be 4 या 3. No, हाँ, it would be 4. 3 होता तो 1 होता ना, 0. इधर की बात करो. इधर threshold for this data set is 4. 3 होता तो even this would have been 1. So yeah, that piece, binarization done. Binning. Split numerical values into bins and encode with a bin ID. Split numerical values into bins and encode with a bin ID. Can be set arbitrarily or based on distribution. Fixed with binning. Does fixed with binning make sense for long tail distribution? That is something that I don't understand right now. 1 2 3 4 5 ठीक है. And this is obviously something, let's say that these are users. Acha, page views by user, and this is the this is what? Okay, this is the user and these are the page views. User count. Acha, these are the pages, and this is the user count. So there 4.5 something users have seen. The two second page को 1 user has seen. Come percentage. Whoa. 65 to 100. Okay, this is a different way to represent the graph. 20 के लिए 100. 20 के लिए 100 कैसे? अच्छा अच्छा percentage में बता दिया. Most users had only one page view during the period. Okay. This is binning continued. Adaptive or quantile binning. क्या बोल रहा है? Adaptive or quantile binning. Divides data into equal portions. Example, median, quartile, deciles. Divides data into equal portions. Example, median, quartile, deciles. Data, red lines are obviously lines of division. Deciles data from review count quantile 1 2 3 4 5 6 7 8 9. Deciles 3 2 458 9 पे 58 कैसे आ रहा है? Why is this such a bad representation of the data man? जब डेटा फ्रेम रिव्यू काउंट है सेल्स 0.1 पे 3 तो ठीक है, डील करना पड़ेगा बने. Log transformation. Compress the range of large numbers and expand the range of small numbers. Example, the larger x is a slower log x increment. तो इधर बेसिकली अपन क्या कर रहे हैं, अपन log x अप्लाई कर रहे हैं. तो log 1 का log ले लिया तो 0.69 1.79. Man, this was my technique. 10 का 20 का. So इतना 1000 तक व्यू काउंट जाने की जगह योर व्यू काउंट हैव यू आर बेसिकली अप्लाइंग लॉग ट्रांसफॉर्मेशन टू, यू आर रिड्यूसिंग डाउन द स्केल. 1000 तक जाने की ज़रूरत ही नहीं है. 6.91 में इतना काम हो गया. स्मूथिंग लॉग टेल डेटा विथ लॉग. तो ये देख रहा है इधर 1000 इधर इतना कम. सो नाउ यू हैव बेसिकली स्मूथिंग द हिस्टोग्राम. लॉग 1 प्लस एक्स, इधर 1 है तो 1 प्लस एक्स किया. Scaling. Models that are smooth functions of input features are sensitive to scale of the input. Example, linear regression. Scale numerical variables into certain range, dividing values by a normalization constant. No changes in single feature distribution. Popular techniques. Min-max scaling, standard z-scaling. Scaling में क्या बोल रहा है? Models that are smooth functions of input features are sensitive to the scale of input. Example, linear regression. Models that are smooth functions of input features are sensitive to the scale of input. Scale numerical variables into certain range, dividing values by a normalization count. No changes in single feature distribution. Popular techniques: min-max scaling, standard z-scaling. Min-max scaling, standard z-scaling. Min-max scaling क्या बोल रहा है? Min-max scaling squeezes or stretches all values within the range of 0 to 1 to add robustness to very small standard deviation and preserving zeros for sparse data. Min-max scaling में zeros for sparse data. अरे यार ये fuzzy वाला है यार. Shit. This is the data set. This is the data 2D list है. Min-max scaler apply किया. X train underscore min-max equals to min-max scaler dot fit transform X train. Because that is done. Values क्या है? -1 0 1 2. ठीक है. 0 को तो भैया प्रेजर्व है. ठीक है. तो -1 1 2. 100 को डिवाइड करो 3 पार्ट में. So that is how your min-max scaler works. Or 0 would become 0.33. That is, this becomes 0.5. It is 0.5 0 and 1. So इधर तो I understand. देखो इधर क्या हो रहा है? 1 -1 and 2. So dividing them onto the scale, ये 0.5 होगा 1 और ये 0 होगा और ये 1 होगा. बराबर इतना समझा. ये 1 है तो ये 0.5 होगा तो ये भी 0.5 नहीं, 0.33 क्यों है? इंटरेस्टिंग. 0 1 0. ना फिर प्रिजर्विंग जीरोस तो इधर क्यों प्रिजर्व नहीं किया? ये मैं खुद एक बार टेस्ट करके देखूँगा. Standard Z scaling. After standardization, a feature has mean of 0 and variance of 1. Assumption of many learning algorithms. Standardization. A feature has mean of 0 and variance of assumption of many learning algorithms. कि mean 0 and variance 1 है. ठीक है। x scale equals to pre-processing dot scale x scale array 0 minus 1 dot 2 1 dot 3, ठीक है। Interaction features. Simple linear modules use a linear combination of individual input features x1 x2 xn to predict the outcome y. Y equals to w आना चाहिए तो अपने को पता है, linear function पता है. An easy way to increase the complexity of linear model is to create feature combinations, non-linear features. Example: degree to interaction features vector x equals to x1 from x2, wx1 wx2 wx3, ठीक है. Interaction feature x1 x2 1 comma x1 x2, ठीक है. इंटरेक्शन फीचर तो ये कोड कैसे करते हैं वो तो पूछने नहीं वाला. जस्ट नीड टू नो कैसे फीचर एंड व्हाट डू दे डू. कैटेगोरिकल फीचर नियरली ऑलवेज नीड सम ट्रीटमेंट टू बी सूटेबल फॉर मॉडल्स. इस चैप्टर के पक्का नोट्स लगने वाले बिकॉज आई डू नॉट अंडरस्टैंड व्हाट एस अ पीपीटी में. देयर हैज टू बी सम स्टैंडर्डाइजेशन हैपनिंग, एग्जांपल्स और ऑल. Categorical features nearly always need some treatment to be suitable for models. High cardinality can create very sparse data. Difficult to impute missing. Examples: desktop, tablet, mobile. Document ID or user ID. Nearly always need some treatment to be suitable for model. Yeah, obviously, your model is not going to understand desktop, tablet, mobile. High cardinality can create very sparse data. Difficult to impute missing. भी desktop और tablet का missing होगा कुछ, mobile तो पता कैसे चलेगा. Understandable. One hot encoding. Transform a categorical feature with m possible values into m binary features. If the variable cannot be multiple categories at once, then only one bit in group can be on. Yeah, obviously. तो डेस्कटॉप और मोबाइल दोनों नहीं हो सकते ना. इट्स लाइक मेल और फीमेल के कॉलम में अगर तुम लोग उसको बाइनरी स्प्लिट दे रहे हो तो वन एक ही जगह लग सकता है बिकॉज इधर यू कैन बी मेल और अ फीमेल. वैसे ही डेस्कटॉप मोबाइल टैबलेट है तो इट्स बेसिकली बाइनरी स्प्लिटिंग और वन हॉट एनकोडिंग कर रहा है. बाइनरी फीचर्स यू डिवाइड द होल थिंग इनटू बाइनरी फीचर्स. जो ट्रू है वहाँ पे वन डाला, बाकी जगह पे ज़ीरो डाला. Sparse format is memory friendly. Example: platform equals to tablet can sparsely be encoded as 2 and 2 is to 1. Example: platform is tablet and be sparsely encoded as 2 is to 1. How? 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 2 is to 1. तो इसको क्या कहो? 1 is to 1 is to 1. What? 1 is to what? I do not understand. लार्ज कैटेगोरिकल वेरिएबल्स, ये सब एक बार समझना पड़ेगा अच्छे से, ये सब नहीं हो रहा है. लार्ज कैटेगोरिकल वेरिएबल्स, लाइक आई एम अंडरस्टैंडिंग व्हाट इज हैपनिंग, बट ये सब एक सिंगल सिंगल लाइन में दे लाइक which do not make sense, like some singular lines are then the PPT that do not make sense to me. Large categorical variables common in applications like targeted advertising and fraud detection. Example: landing page, ad ID, publisher. Some large categorical features from outbound click prediction competition. So landing page, document ID, obviously landing page will have the most unique values. Ad ID, ad document ID, content entities, ठीक है. Feature hashing hashes categorical values into vectors with fixed length. Hashes categorical values into vectors with fixed length. Lower sparsity and higher compression compared to OHE. Hashes categorical values into vectors with fixed length. Lower sparsity and higher compression compared to OHE. Deals with new and rare categorical values. Example: new user agents may introduce collisions. कोलेजन तो दिख रहा है मेरे को. कंट्री हैश 3 कैसे बोलूँ? ठीक है. Instead of remembering all the country के names, two names, you hash it down. to form a matrix of 100 columns, because there are 100 unique country names I believe, और जहाँ पे भी जो भी ट्रू है ना वहाँ पे वन डाल दो. This is helpful because you do not require the name, you already have it hashed. Plus it can be infinite, तो तुमको को बस एक कॉलम मेंटेन करना है instead of remembering different types of country names. And ones or zeros is definitely better to deal with in model training, because at some point you'll anyways need to convert them to a form that the model needs to understand. और ये ऐसा नहीं समझने वाला उसको. Binary counting, bin counting, okay. Instead of using actual categorical values, use a global statistic of this category or historical data. Useful for both linear and non-linear algorithms. May give collisions. Same encoding for different categories. Be careful about leakage. Strategies count average CTR. Ad views, ad clicks, counts, click-through rate. Though they look the same, that is a whole different thing. Click-through rate. Temporal features. Temporal features में क्या है ना? Factors to consider. Multiple time zone countries, daylight saving, start and end daylight saving dates. For those who do not know what is daylight saving time, okay, that is gonna be a fucked up concept for you to understand right now. Suppose you live in a country जहाँ पे you receive less daylight, and all the daylight that you receive is before 4 in the afternoon. So you would technically adjust your clock to go back by 3 hours, 2 to 3 hours, so that you have more daylight and your working hours or your working time span, or like जो अपने इधर है, matches your daylight zone, and then you fall back to the night with the wrong, like the added on or the corrected date time or date hours, time hours, sorry. So that is daylight saving time. That is why many programmers have this whole confusion of क्या कौन से date पर, because you have to match to even like teams की meeting app पे some country might be having daylight saving, some might not. Forget countries, there are regions, and that is how they have been split. India luckily has only one time zone, but something like Australia has three. USA itself would have one, two, three, four, five, six, and all these red points you see, those are daylight saving zones. So there, people just decided that we want a daylight saving zone to happen. Mans. So offsets दिख रहे हैं सबके, और डे टाइम सेविंग टाइम के ऑफसेट्स दिख रहे हैं सबके. वैसे भी 2 घंटा आ गया है, उसमें भी एडेड वन मोर आवर. ठीक है. टाइम बिनिंग. Apply binning on time data to make it categorical. Apply binning on time data to make it categorical and more general. Binning a time in hours or periods of day, like 5 to 8 के रेंज में 1 है, 8 to 11 की रेंज में 2 है, 11 to 14 की रेंज में. ओके, सो तुम लोग ने आर रेंज को बाइनरी आईडीज दे दी है, एंड ईच बाइनरी आईडी हैज़ अ डिस्क्रिप्शन, एक्सट्रैक्शन, वीकडे, वीकेंड, वीक, मंथ्स. ठीक है, दिस इज सिंपल. This is what time binding. Trend lines. Instead of encoding total spend, encode things like spend in last week, spend in last month, spend in last year. Gives a trend to the algorithm. Two customers with equal spend can have wildly different behavior. One customer may be starting to spend more while the other is starting to decline spending. Spatial features. Spatial variables. Spatial variables encode a location in space, like GPS coordinate. ठीक है. Spatial data to we know, street addresses, zip codes. ठीक है. Derived features, distance between a user location and search hotel, Expedia competition, impossible travel speed, fraud detection. Yeah, impossible travel speed is one thing. Like if your car, according to the data provider, just reached from here to Delhi in like 1 minute, that is impossible travel speed detected. So that is a fraud that is happening on The GPS system, textual data, natural language processing. That's cleaning, that is lowering the case, convert accented characters, removing non-alphanumeric, repairing. Then there is removing stop words, rare words, common words. There is tokenizing, encoding, punctuation marks, tokenize, engrams, skip grammars, charactergrams, affixes, roots, spelling correction, chop, stem, lematize, enrich, entity insertion extraction, parse, trace, reading levels. Wow, बहुत कुछ होता है नेचुरल लैंग्वेज प्रोसेसिंग में. Text vectorization. Represent each document as a feature vector in the vector space, where each position represents a word token and the contained value is its relevance in the document. VOW's bag of words, TF-IDF, term frequency, inverse document frequency, embedded top model, Linux modern the system steering petrol. डॉक्यूमेंट वन में इतने टाइम से वर्ड का काउंट आया था, डॉक्यूमेंट टू में इतना, डॉक्यूमेंट ब्लैक अप पे. टेक्स्ट वेक्टराइजेशन, TF-IDF tokens. I do not understand how is he still gonna ask. Cosine similarity. Similarity matrix between two vectors is cosine among the angles between them. Feature selection. Reduces model complexity and training time. Filtering. Example, correlation or mutual information between each feature and the response variable. Wrapper methods. Expensive. Trying to optimize the best subset of features. Stepwise regression. Embedded methods. Feature selection as a part of model training. More data beats clever algorithms. Much better data beats more data. Wow. Some machine learning projects succeed and some fail. Where is the difference? Easily the most important factor is features used. Wow. Okay. Just because ये हो गया, we'll go through this once with little understanding of how questions will be formed. I just think ऐसा mention the types and all वाले questions ही हो गए. जो इधर तक सब क्लियर है. क्लिक थ्रू रेट भी क्लियर था. डेटा मंगिंग what are predictive features? Yeah, there's no definition given. Pivoting, there is aggregating, there is pivoting. Some numerical features आ गए. Numerical features may usually easily to ingest by mathematical models, but feature engineering is indeed necessary. Imputation में missing values भी आता है. Binning हो गया. Log transformation हो गया. Min max scaling में min max आ गया. Standard Z scaling आ गई. Categorical features हो गए. Large categorical variables. Bin counting हो गया. Temporal features में टाइम बिनिंग हो गया. स्पेशल फीचर्स में ग्राफ, अरे जियो जिप कोड्स, कोऑर्डिनेट्स, डिस्टेंस, स्पीड, वो सब हो गया. टेक्सचुअल डेटा में NLP आ गया. टेक्स्ट वेक्टराइजेशन, दैट इज गिविंग अ टेक्स्ट काउंट. TF-IDF देखना पड़ेगा. फीचर सिलेक्शन में फिल्टरिंग, रैपर मेथड्स, एम्बेडेड मेथड्स हो गए. कोरिलेशन और म्यूचुअल इंफॉर्मेशन बिटवीन ईच फीचर एंड this is expensive because trying to optimize the best, because here we use machine learning. Embedded methods, feature selection as a part of model training process. Embedded methods, the feature selection as a part of, जैसे ही model train होता है ना तभी we see what is giving us better accuracy. ठीक है, that is the PPT done. That is very weird. Still don't understand questions कैसा आएगा.